Good morning, students. Am I audible, visible? Please write in the chat box. Am I audible? Yes. Let's start. Today we'll discuss about the determinant. Write down arrangement of square number of elements arrangement of square number of elements in equal number of rows and columns is called a determinant. Arrangement of square number of elements in equal number of rows and columns is called a determinant. Square number of elements means either 4 elements or 9 elements or 16 elements or 25 elements like this, okay? In equal number of rows and columns, horizontal lines are called rows, vertical lines are columns. Suppose 2 horizontal lines are there, row 1, this is row 2, and 2 vertical lines, column 1 and column 2. So what is the total number of a point of intersection? The total number of a point of intersection is 4. If each point of intersection is occupied by an element, so there will be 4 elements. Suppose this element is A, this element is B, this element is C, and this element is D. So the determinant can be written as A, B, C, D. Okay, this is called a determinant. If we have 3 rows and 3 columns, row 1, row 2, row 3, and 3 vertical lines, column 1, column 2, and column 3. There are 9 points of intersection. Suppose this point of intersection is occupied by A. This is B, C, D, E, F, G, H, I. So the determinant can be written as D is equal to ABC, DF, GHI. I hope it is clear to you. बुझी पाले पहले चैट बॉक्स में लिखी जोना बुझी वाला ना नहीं. हेलो राजलक्ष्मी, सौम्यजीत, okay, then write down order of the determinant. Order of a determinant. Good morning. In a determinant, the number of rows is equal to number of columns. Write down if a determinant contains m number of rows and m number of columns, then the order of the determinant is m. If a determinant contains m number of rows and m number of columns, then the order of the determinant is n. If the determinant contains 2 rows and 2 columns, then the order of the determinant is 2. If the determinant contains 3 rows and 3 columns, order of the determinant is 3. If the determinant contains 4 rows and 4 columns, then the order of the determinant is 4. So first of all, we have discussed about a second order determinant. Second order determinant. Second order determinant contains 2 rows and 2 columns. Row 1, row 2, column 1, column 2. The element which is present at the intersection of a first row and first column is generally denoted by A11. Element present at the intersection of first row and second column is denoted by A12. Element present at the intersection of second row and first column, A21. And element present at the intersection of second row, second column is generally denoted by A22. So Aij represent the element. Aij represents the element present at the intersection of ith row and jth column. Okay. In Aij, the subscript I represents row number and the subscript j represents the column number. The subscript I represents row number and the subscript j represents the column number. So Aij represents the element which is present at the intersection of ith row and jth column, right? So the general form of a second order determinant is D equals to A11, A12, A21, A22. Okay, this is the general form of a second order determinant. A second order determinant contains 4 elements, 2 elements in first row and 2 elements in the second row. Okay, so there are 2 diagonal elements. This is a diagonal, this is another diagonal. This diagonal, the diagonal which connects left upper corner to right lower corner, is known as leading or principal diagonal. Leading or principal diagonal the element, and this diagonal which joins right upper corner to left lower corner. This is called secondary diagonal. This is called secondary diagonal. Okay. Then come to evaluation of a second order determinant. Evaluation of a second order determinant. Evaluation of a second order determinant. D equals A11, A12, A21, A22. So the value of a second order determinant is equal to product of the elements in the leading diagonal, that is A11 into A22, minus product of the elements in the secondary diagonal. So value is equal to product of element in leading diagonal minus product of elements in secondary diagonal. So value of this determinant is equal to A11 into A22 minus A12 into A21. Product of the elements in the leading diagonal minus product of the elements in the secondary diagonal. I hope it is clear to you. Did you understand, guys? Please write in the chat box. Is it clear? बुझी पार्छु कि पिले चैट बॉक्स रे लेख बुझियला ना नहीं Padampur. So let's come to solve couple of questions. So evaluate or find the value of D equals to 2, 3, minus 1, comma 4. 2, 3, minus 1, 4. Okay. So value of this determinant is equal to product of the elements in the leading diagonal. That is 2 into 4 minus 1 into 3. 2 into 4 is 8. Minus 3. Minus of minus is plus. 8 plus 3 equals to 11. Okay. So write down. Try to solve these questions. Evaluate the following. Where I is equal to root over of minus 1. Where I is equal to root over of minus 1. And omega is the cube root of unity, imaginary cube root of unity. Omega is the imaginary cube root of unity. Omega is the imaginary cube root of unity. Okay. Take 5 minutes of time and solve these 4 questions. Number 3, answer -3. Number 3. How come it is -3? 2 into 1 is 2. Minus I into I is I square. I square is equal to -1. 2 minus of -1. 2 plus 1 is equal to 3. So answer to question number 3 is 3, not -3. Yes. Samyaji, question number 3, answer is 3. Pankaj is right. Okay. What is the answer to question number 4? Question number 4. This is equal to omega into 1, that is omega, minus omega into omega, that is minus omega square. This is equal to omega plus of omega square. So, if omega is the cube root of unity, then 1 plus omega square, 1 plus omega square is equal to 0. This implies omega plus omega square equals to -1. So answer to question number 4 is -1. Question number 1, this is equal to 6 minus 8. This is equal to -2. Question number 2, sin square theta plus of cos square theta. Sin square theta plus cos square theta is equal to 1. Sin square theta plus cos square theta is equal to 1. Right? Then write down third order determinant. The general form of a third order determinant is third order determinant contains 3 rows and 3 columns. A11, A12, A13, A21, A22, A23, A31, A32, A33. This is a general form of third order determinant. Okay. For example, D equals to suppose 2, -1, 5, 4, 3 minus 2, 6 minus 5, 7. This is a third order determinant. Okay. To evaluate, to find the value of a third order determinant, we should know about minor and cofactor of an element with respect to a determinant. Write down minor. Minor of an element. Minor of an element Aij with respect to a determinant minor of an element Aij with respect to a determinant is an element or the value of the determinant left over after deleting the ith row and jth column elements. Okay. So minor of an element Aij with respect to a determinant is an element or the value of the determinant left over after deleting the ith row and jth column element. For example, let us take a second order determinant. D is equal to A11, A12, A21, A22. Okay. If we want to find the minor of A11, A11 is present at the intersection of ith row and A11 is present at the intersection of first row and first column. To find the minor of A11, we have to delete the elements those are present in first row and first column. After deleting these elements, what is left over? An element is left over, that is A22. So A22 is the minor of A11. Similarly, if we want to find the minor of A12, A12 is present at the intersection of first row and second column. We have to delete the elements in first row and second column. What is left over? A21 is left over. So minor of A12 is A21. Similarly, minor of A21 will be A12 and minor of A22 is A11. Okay. So in a second order determinant, minor of an element is the diagonally opposite element. Okay. Quickly note it down. In a second order determinant, minor of an element is the diagonally opposite element. Write down the note point. Yes. In a second, if D is a second order determinant, D is equal to suppose A11, A12, A21, A22, right? ଆମେ ଯଦି A11 ର minor calculate କରିବା ଆମେ ଦେଖିଲେ A11 present at the intersection of first row and first column. ତାହେଲେ A11 ର minor calculate କରିବା ପାଇଁ ହେଲେ first row first column ର element को ଆମେ delete କରିଦବା ଆଉ ଯାହା ବଳି ପଡିଲା କଣ ପଡୁଛି A22, so A22 is the minor of A11. Similarly, if you want to find the minor of A12, A12 is present at the intersection of first row and second column, so first row second column elements should be deleted. After deleting the first row, second column elements, what is left over? A21 is left over. So A21 is the minor of A12. Right? Did you understand? I think. Okay. So in a second, write down in a second order determinant, minor of an element is the diagonally opposite element. In a second order determinant, minor of an element is the diagonally opposite element. Momonos? Management class? In a second order determinant, minor of an element is the diagonally opposite element. That is, D is equal to suppose D is equal to A11, A12, A21, A22. So diagonally opposite element of A11 is A22. So we can write minor of A11 is A22, minor of A11 equals to A22. So minor of A12 is diagonally opposite element, that is A21. Minor of A21 is A12 and minor of A22 is A11. I hope it is clear to you. Please write in the chat box. Bujiparla ki pile chat box ro lekho. Bujiela what is minor? Then come to a second order, the third order determinant. D is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. Right? This is the third order determinant. Suppose we want to calculate the minor of A11. A11 is present at the intersection of first row and first column. To find the minor of A11, we have to delete the elements those are present in first row and first column. So these are the elements. So we have to delete first row and first column elements. After deleting the first row and first column elements, what is left over? A second order determinant is left over. This is a second order determinant. So value of this second order determinant, value of this second order determinant, value of this second order determinant is minor of A11. And you know, value of this second order determinant will be product of the elements in the leading diagonal minus product of the elements in the secondary diagonal. So value of this determinant is A22 into A33 minus A23 into A32. So we can write minor of A11 equals A22 into A33 minus A23 into A32, right? If you want to calculate or find the minor of, A23, suppose we want to find the minor of A23. A23 is present at the intersection of second row and third column. To find the minor of A23, we have to delete the elements present in the second row, that's these elements, and third column elements. After deleting these elements, what is left over? A second order determinant is left over, this determinant. That is A11, A12, A31, A32. Okay, so we can write minor of A23, minor of A23 is the value of this determinant, that is A11 into A32 minus A12 into A31. Is it clear to you? Did you understand, guys? Please write in the chat box. बुझिए लग नहीं chat box में लिखो. Then we will move forward. Okay. So write down a question. Find the minor of each element and the minor of each element of the determinant and the minor of each element of the determinant D equals 2, -1, 3, 4, 1, -2, -3, 5, 6. Okay. Find the minor of each element and send me the answer through chat box.